we begin where we left in the previous class. I was talking about a very simple, very simplistic form of a multiplier that may exist in the monetary sector. And I try to explain that in terms of a reserve change with one bank, how when that is given out as a loan, shifts from one bank to another bank through the system, that money, and creates what is known as credit multiplier. Now, this credit multiplier, the algebraic part is simple. The total change in deposits is the initial change in reserves divided by R, where R is CRR. Now, in this formulation that we obtained that day, the multiplier is 1 over R, small r. We are assuming a number of things. When the money leaves first bank as a loan to somebody, it leaves in the form of a check, not cash. In case of a cash, if the money leaves, some cash may remain with the person and some may get deposited in another bank. But here there is an assumption that nothing remains in cash form. It leaves in the form of a check which he goes and deposits in his own bank, and if he has an account, assuming he has an account, and puts the money there. Again, when it leaves in the form of a check to somebody who goes and deposits in his bank, and there is no cash part of that money that remains in the economy. Number one, very simple assumption. Otherwise, it will be only a portion of that loan getting deposited in another bank. Second, when banks receive deposit money, savings account, etc., they keep a part as excess reserves with them, because this is the cash with banks. Banks need a part of that to be kept as cash, primarily that the person who has deposited the money may come tomorrow or day after tomorrow and say, I need some of my money. Now, if the bank gives out the entire money that it received as deposit from you to some person as a loan, where would the bank give the cash to him? So, there is a calculation that bank does. How much is this part of the deposits I need to keep as cash with me, which we do every day in the bank, cash withdrawal. लाइन में खड़ा है आदमी, चेक लिख रहा है, कैश ले रहा है, घर जा रहा है. किधर से कैश हो रहा है? अपना अकाउंट से, अपना डिपॉजिट से. So bank have to calculate, banks do calculate the amount of cash they should withhold, and then the CRR money which goes to the reserve bank. After deducting all this, maybe a safe zone also, another percentage, then whatever remains, they think now how much of that can be given out as loan, which even if it is returned 2 years later, 1 year later, I do not have any problem in managing my cash with my clients who are depositing money. So, this is where banking, a core area of banking that one does have to have an aptitude to be a banker. There are many other things that bankers need to have as a skill or qualification to run a business successfully. There where banks failure occur, when they give out too many loans and that are bad loans which are not returned, then when depositors come and ask for cash, they do not have cash. So, bank mein tala laga dete hai. That is called a bank failure. That is why the CRR was created after the depression, that there is a safe money somewhere, a precautionary deposit with the central bank. So, in case I mismanage my funds for whatever reasons, if tomorrow depositors come, I have no problem, no panic. I can just simply tell RBI, and RBI will help me out. All right. So, this has a number of simplifying assumptions, this model. What I need to tell you now is all along what I was trying to tell you, that the monetary base of the economy is one which is very important to the policymakers to watch what are the sources from where money is coming into the monetary base, which is continuously expanding or contracting, very alive thing. And if it does, then the superstructures which we call money supply or monetary aggregate, they also keep on expanding and contracting. What is the connection? The connection between monetary base and a monetary aggregate like M1 or M3, which are commonly found in government documents. Government documents usually have only M3, not M1, but we will do M1 also. What is the connection? The connection is again through a multiplier, which we are familiar with in macroeconomics. The something happens, there is a multiplied effect on something else. Government expenditure increases, there is a multiplied effect on total output or income in the economy. Similarly, monetary base changes, there is a multiplied effect on monetary aggregate. That what we will do now. The connection, these are called money multipliers. This is very simplistic, oversimplified. So, we will talk about money multipliers now. Essentially, I will talk about two money multipliers. One, the relationship between M1 and call that small m1 into m0. This small m1 is the simple money multiplier. So, what I am saying, if monetary base changes, the effect of M1 will be via a multiplied effect. It will be a multiplied effect which depends upon M1, which is the simple money multiplier, because I am talking about the narrow money relationship. One more multiplier I will do, the complex money multiplier, which is the relationship between M0 and M3. I will do that later. Let us look at this, how it is obtained. It is obtained very mechanically. What we do usually, can find many references, is that let us recall the definitions. M0 was C plus R. C was currency with the public. Was that the definition I used? Notation? Okay. And M1 is currency with the public plus demand deposits, call that D. Here D is demand deposits. What is the other thing in M1 and M0? Other deposits. I am ignoring them. Other deposits, I am ignoring them. They are very small amount. Now, you can do a simple manipulation, which is M1 is equal to M1 over M0 into M0. I can write that. So, this relationship will therefore become M1 is equal to C plus D over C plus R into M0. Now, R has two types. R has two reserves. One is the required reserve, the CRR, another one is cash with banks called excess reserves. So, this can be rewritten as C plus D divided by C plus RR plus ER. m naught. All right? Okay. Now, divide numerator and denominator by d. So, what you have is c over d plus 1 divided by c over d plus rr over d plus er over d. Now, as soon as you do that, you notice one thing. In economics, we call they are behavioral assumption. They depend upon the behavior, an average behavior. So, what is the behavioral assumption I am going to make, or behavioral parameters that emerge? Economics, particularly microeconomics, is entirely behavioral economics. Companies maximize profit, individuals maximize utility, all behavioral assumptions. All right? There can be an individual who does not maximize utility, maybe maximizes disutility. But we do not think that is an average, that is normal. So, we make behavioral assumptions. The behavioral assumption here is very simple. What are the behavioral characteristics that emerge is very simple. C over D is essentially saying that when a person receives money, how much of that it wants to keep with himself as cash and how much it wants to put in the savings account, where if required they can go, and these days even they can go to an ATM machine and get the cash out. So, how much it will be, it will remain as cash with himself, and how much his own money he can put it in the bank in a savings account and earn some interest rate and be safe. चोरी भी हो सकता है ना, पूरा सैलरी हमको मिला, मैं कैश रख दिया घर में, तो रेव में गए मस्ती करने, शाम को रात को जब आए कैश गॉन. So, there can be various reasons why individuals behave in certain way. They behave when they receive money with a banking system around, that they could withhold some cash and the remaining salary can be in the bank, and whenever they need money they can go to the bank. And also the advantage is, if it is as a checking account, some payments can be made with checks, and you cannot make that unless you have the cash in a bank deposit. How can you make a check? How can you write a check if you do not have an account? So, this is a behavioral characteristic coming out that is emerging from my manipulation here, C over D. Then RR over D is a typical RBI instruction. How much of D you will have to part and keep with us? The deposits that you get, demand deposits to savings account, current account, etc., you will have to keep with us. That is an RBI instruction. So, that is a policy parameter, that is a monetary policy parameter, central bank's parameter there, all right, that depends upon central banks. This is essentially the small r I talked about, nothing else, required reserve ratio, CRR, but CRR is simple CRR, CRR is more complex, I am coming to that. And this is a bank's behavioral parameter here, ER over D. Typically banks, when they receive cash through deposits, they decide how much they will like to keep in cash form with themselves in vaults, etc., lockers, and every day they bring that out, or whatever amounts are required when customers come and demand their own money. Okay. Suppose I have 1 lakh in my account, and my typical habit is every 15 days I go there and withdraw 20,000. I am just saying it. So, this is what the banks need to study, what is the behavioral behavior of these clients as to how frequently they withdraw money and how much do they withdraw money, some average. So, this is bank's behavioral parameter that may emerge here. ER, excess reserves, the cash banks keep for you and me, because our money is with bank, over the total deposit they received as demand deposits. Clear? All right. Now, what we need to do in this case is very simple. Let us give them a name, small alphabets. and we can write m1 is equal to 1 plus, call that small c, and let it be small c plus small r plus small e into m naught, where small c is the currency to deposit ratio, small r is the required reserves over demand deposit, small e is equal to excess reserves over demand deposits. All right. And you can see one thing, all these parameters are less than 1, magnitudes are less than 1. All these parameters, magnitudes are less than 1. So, this is less than 1, this is less than 1, this is less than 1. Now, we can finally conclude that m1 is equal to small m1 into m naught, where small m1 is equal to 1 plus c over c plus r plus e. Now, question is small m1 greater than 1 or less than 1? Typically, this number is very small. This is about 7-8%. All right. So, it depends upon these two numbers are less than 1 and c is common and 1 plus c. So, it is definitely greater than 1. Here you have the simple money multiplier. So, just the way human beings are and what banks do to people, a multiplier is born, and that exists. I am trying to show that to you with the help of some simple notations and algebra. It exists, and that is precisely what happens when monetary base changes, because an exporter went abroad, sold something, came back to India with dollars, goes to RBI, converts the dollar into Indian rupee, then he decides to keep a part of the Indian rupee as cash and put that part, the other part in deposits, in this case only demand deposits. So, this is not a very realistic multiplier. I am coming to the other multiplier which is more realistic, and banks behave in certain ways, keep the part of the deposit with RBI on a fortnightly basis or weekly basis and keep excess reserves. A multiplier is born, which we do not realize unless we go through this process. So, if monetary base changes by some number, let this number be 2, suppose. So, if monetary base changes by 100 crores, M1 changes by 200 crores. This is what RBI keeps track of, and this is what your macro textbooks tell you about M. They do not tell you how M changes. They say, suppose M changes, LM shifts, but this is the route through which M changes. All right? But this does not make economists happy, because here when deposit money comes, it is just not demand deposits in a country. People keep a whole lot of money, particularly who earn well, in fixed deposits. So, we need to talk about a multiplier where time deposits come, and therefore, we need to talk about the complex multiplier, which is the relationship between M3 and N naught. So, that is the next task, M3 and M naught. Is this part clear? Currency to demand deposits? Good point. Very good point. Usually people do, but likewise suppose you receive a salary, but it may not be. Yes, I agree. Some cases may not be. We need to see empirically what is true for India. You receive salary beginning of month, you keep some cash for payments and you have to live through the months. So, the cash that you will keep, will it be less than the money that you will keep in the bank? Usually it is. because the rest of the month you have to live on that money. So, the fraction that you keep as cash is normally less than the fraction that you keep in your account. These days what happens with IIT etc., the salary is not given to me in cash form, salary is deposited in my account, and I definitely withdraw a fraction and keep more there, less than 50%, I definitely withdraw, because with that salary I have to live. Normally that is true, but it may not be, yes. So, it is a behavioral property, we need to check that empirically. Not a bad question. Why, sir, are you making it less than 1? Yeah, some people may be crazy, they live on borrowed money maybe. So, whatever money they receive, they spend most of it in the first 10 days or 15 days, then the deposit that you keep in bank is definitely less than the currency that you withheld. But normally that should not be the case. So, I am calling it behavioral property or assumption or feature of the model. Behavioral means how human beings behave, and that you model into your discussion, that you consider in your discussion. In economics, we do that this kind of a way, this kind of a method we use. Acha, let us go into complex multiplier. Now, can anybody give before I go to complex multiplier, can anybody tell me how M1 and C, these derivatives would work? I am now going to make your life a little bit more. Can anybody tell me di M, di C, di M, di R and di M, di E, what these multipliers would be, partial derivatives, what these partial derivatives would be? A multiplier, how it changes when, suppose, as he asked me, suppose the currency to demand deposit ratio increases, how would the multiplier change? So, this M1, you call that M1 maybe, how does M1 changes? Di M1 di C, what will be the derivative? You have numerator, denominator, both places C. If currency to demand deposit ratio small c changes, say increases, people decide to keep more cash and keep less money with banks. How would the multiplier get affected? This is an important question. This we should answer before we go into the complex multiplier. Di M1 di C greater than 0? Less than 0. Chalo, open karo, ye algebra karo, di M1 di C. Otherwise, my notes are, I am assuming R and E are less than 1, of course, they are less than 1. So, will it be greater than 0 or less than 0? Less than 0. And what will be the famous policy multiplier, which is very important, or everybody wants to know, if central bank increases CRR, what will happen to the multiplier? Di M1 di R, what will it be? Less than 0. Now you understand monetary policy, why central bank increases CRR. When central bank increases CRR, that essentially means central bank is opting for tight money policy, and tight money policy essentially means that it is going to control the money supply by shrinking it, by shrinking the multiplier. So, when M0 changes, the effect, the impact on M1 will be less. So, it can directly hit the multiplier through CRR number. So, when central bank says from tomorrow, it does announce on TV, I have seen, Reserve Bank governor himself comes often. Tomorrow we are going to make CRR to go up by 50 basis point, that means it is now 7, it will become 7.5. You know what they are trying to do. They are trying to shift the LM curve or control the LM curve, which has been shifting out, so that it does not shift out so much. All right. So, it is trying to also control the outward shift of the demand curve, and therefore, it is trying to control maybe something like inflation, because when demand shifts out, supply, if it does not change much, prices will go up. So, one indirect way of controlling inflation would be a tight money policy, where central bank can announce, let us increase CRR. Is this becoming clear now to you? This is often on TV, and this is precisely what the reason is. That is why those partial derivatives are very important. If banks decide to hold more cash as excess reserves because people are withdrawing too much, say Puja vacation is coming, Dasera, when people spend more than the normal. So, banks at that time keep more cash. So, if E goes up, what will happen to the multiplier? Die M1 die E, again negative it will be. The multiplier shrinks. You see that? So, this is very important, these partial derivatives. This is less than 0, this is less than 0, this is less than 0. Okay? So, I am just not teaching money and banking, I am into monetary policy also in this course. Otherwise, it does not make much sense to talk about just money and banking, isolated way. Achha. Now, I come to the actual multiplier, which you open a government document like economic survey, you will see the numbers and the plots also. I will also give the plots. I created my plots. You open economic survey today, you will find that it is there. It is called a complex multiplier. The complex multiplier is essentially the relationship between M3 and M0. Call that M2. So, broad money, how it changes with M0. So, recall the definitions. And ignore other deposits. M3 is currency plus demand deposits plus time deposits. All right, demand deposits plus time deposits, and M0 is currency plus required reserves plus excess reserves. This is what you have. So, we can write following the same method, we can write M3 is equal to M3 over M0 into M0, which is C plus D plus T divided by C plus RR plus ER. Now, if you divide it by D, then you have C over D plus 1 plus T over D. Then you have C over D plus RR over D plus ER over D into M0. Now, we have an extra complication here. We have time deposits. Now, the story is complete. Go to bank, you can open either of the two accounts types, demand deposit account, which we are savings account, etc., where you can demand your cash when you want. Time deposit, your money is stuck there. 2-year fixed deposit, 3-year fixed deposit, 4-year fixed deposit, whatever. So, there is a behavioral pattern. Now, we need another parameter, T to D ratio. All right? Okay. Let us now consider the following. Assume two more things. One, the required reserves are the real required reserves. That what happens. Some rho, that's not rho, that's gamma. Gamma, which is a proportional factor of D plus T, where gamma lies between, and this is the CRR, actual CRR. CRR is just not out of savings accounts. That's a simplified CRR. This is the actual CRR. CRR money comes from both demand deposit accounts and time deposit accounts. Both accounts are taken for CRR money. So, this is the real CRR. Second, let us assume that the time deposits grow in proportion to demand deposits, where T is just simply a positive number. Time deposit to demand deposit, there is a behavioral relationship in the economy. People want to keep this much money in savings account and put this much money in the fixed deposit accounts, long term deposits essentially. One short term deposits, one long term deposits, and people decide that at home. Often parents sit down, father and mother, and they decide how much to keep the money in fixed deposit and how much to keep in savings account. I mean, you ask them, you will hear that. It is very much a human decision, a behavioral decision. So, now I can make these relationships using these two assumptions. I can simplify that here. So, this becomes therefore M3 is equal to small c plus 1 plus T over D. Now, if you substitute this, D cancels out, it will be small t, divided by what you have is again small c plus gamma plus this one is going to create some trouble, RR over D. RR is gamma into D plus T. So, now T is TD. So, it will be gamma D into 1 plus T. So, it will be gamma and divided by D cancels out, it will be gamma into 1 plus T. देखो भाई समझ पाए तो आज एक कॉम्प्लिकेशन इधर था क्योंकि ये RR is now a proportion, it is a proportional relationship with D plus T. So, you have to substitute for T first, TD, factor out D, 1 plus small t, and then D divided by D cancels out gamma into 1 plus small t, Shanti Mila, into M naught. So, this is the complex multiplier where M naught is equal to 1 plus C plus T over C plus gamma into 1 plus T plus E. The question is it greater than 1 or less than 1? E is a very small fraction usually, 1 plus C plus T. Now, gamma of 1 plus T is a fraction of that 1 plus T here. Gamma is 7% or something. So, 7% of 1 plus T is a small, plus C is definitely less than that, And how much E would you add? Very little E you have added. So, it is greater than 1. Intuitively you can see it is a greater than 1 number. You understand what I am saying? Gamma CRRs, how much can it be? Maximum CRR is probably 15%. So, 15% of 1 plus T, and it is less than 1% usually E. We will check that number out for India. We will check those numbers out, actual numbers I have. So, now 2-3 classes we will have on data to see actually what numbers are there in India. We need to see that. So, 1 plus C plus T, C plus gamma into 1 plus T plus E is going to be greater than 1. Complex multiplier. In India, we need to check the complex multiplier, and this is RBI is checking. Government even reports in economic survey, Ministry of Finance, if you open economic survey, you open economic survey for fun in the evening and check M3 numbers there. There is a chapter on money supply, monetary developments or monetary sector, something it is called. M3 is plotted there. So, this is this complex money multiplier, which is a relationship between monetary base and broad money, is of prime interest to policymakers like government, like central bank, of course, banks, everybody. Most people are interested in this. Whoever is interested with macroeconomics is interested with this, or the macroeconomy, they are all interested with this. Now, please check the derivatives. The derivatives you need to check now, di M2, di C, di M2, di the CRR, di M2, di T, and di M2, di E. Check the derivatives. This is the most important one from the policy point of view. The other ones are behavioral patterns. What do they show? If people are putting more money in fixed deposits, if people are keeping more money in fixed deposits, what will happen to the multiplier? Simple questions can be asked. If people want to keep more money in fixed deposits, what multiplier will you have? I think what will happen is we need to check them out. Can you please check the multipliers, these derivatives? I tell you, my notes are with ink corrections. I mean, I made error in the past. Simple calculus is required. But what I have is di M3, di policy parameter gamma is less than 0. So, our policy result which we got earlier holds here too. Di M3, di E is also less than 0, bank's behavior. Di M3, di C less than 0 under certain restrictions, which is all right. The restriction is 1 minus gamma into 1 plus T should be greater than E. No? Less than E, then it is less than, otherwise greater than 0. So, check that number, di M3, di C. When you differentiate di M2, not M3, di M2 with respect to di C, what will it happen? You tell me what algebra do you have? My algebra is incorrect here. Greater than E to be, so you have E minus, now you have E minus 1 minus gamma into 1 plus T, is it correct? Divided by C plus gamma into 1 plus T plus E square, whole square, all right? E minus it will be. I have written it incorrectly. E minus, all right. So, it will be less than 0 if E minus this where essentially you are saying 1 minus gamma into 1 plus t is greater than E, which is reasonable. E is a very small number. I will just check. 1 minus gamma will be say like 93%, and 1 plus t, t is usually greater than 1 number. T is greater than 1 number. So, 1 plus t is greater than 1 of course, and 1 plus, so has to be greater than E, so it is less than 0. So, if people decide again the same result holds, if people decide to hold more cash, put less money in the bank, even the complex multiplier will say that the multiplier strength will weaken. Multiplier strength will weaken if central bank decides to increase CRR. Multiplier strength will weaken if banks decide to keep more cash. Now comes the T. If people decide to hold more fixed deposits than demand deposits, what will happen to the multiplier? Can you find that out? Di M3 di T, what that algebra will be? Greater than 0. My result is 1 minus gamma into C plus E, clear? Divided by a whole square term. Now, 1 minus gamma into C plus E is greater than 0. Unambiguously. So, 1 minus gamma into C plus E. So, what you are saying, in an economy when the time deposits increase compared to demand deposits, which you can check by plotting time deposit values and demand deposit values, simply 2 lines, and you see the time deposit number goes up like this and the demand deposit number is like this, suppose. You can close your eyes and you could say the complex multiplier is becoming stronger and stronger, ceteris paribus, given other things not changing much. All right. So, the question is now multiplier number for any year would be a net result of all these parameter shifts C, T, gamma, E. Net result. So, we need to see what is happening in India. So, that data will be coming up. Actual numbers for monetary aggregates. ठीक है?